Sometimes what we need is a line segment rather than an entire line. So here we're going to find a vector equation for the line segment from P to Q, where P has coordinates x0, y0, z0, and Q has coordinates x1, y1, z1. I think this will go a lot easier if we use some colors, and so I'm going to make that happen here. Now, having done that, this will go easier if we consider the points to be the head of, each one to be a head of a vector in standard position. So we're going to call the vector r0 the one associated with the point P. So r0 is the vector x0, y0, z0. And then for the point Q, we're going to make that the head of the vector r1. So r1 has components x1, y1, z1. Now, we are talking about a line segment, so we're going to develop this as though we were developing the equation of a line. What we need is a direction vector, and it's important that our direction vector goes from P to Q. So our direction vector from P to Q, we'll call it V, and it's going to be, its components are going to be coordinates of Q minus coordinates of P. Now remember that the equation of the line through P and Q with direction V can be given by r of t is equal to r0 plus tv. For what we have, that means we're looking at the vector x0, y0, z0 plus t times v, which I'm going to copy because it has all those colors. Now if we gather together kind of our colors on the right, what we're going to do is we're going to distribute the t throughout the second vector. And then we're going to gather together our x0s, and then our y0s, and our z0s, and so on. We're going to end up with r of t is equal to, for our x components, if we gather together x0s and then factor out x0, we end up with 1 minus t times x0. And then if we keep distributing here, we end up with plus t x1. Likewise for y and z. And this we can factor and split into two separate vectors. We end up with 1 minus t times the vector x0, y0, z0 plus t times the vector x1, y1, z1. We can rewrite this as r of t is equal to 1 minus t times the vector r0 plus t times the vector r1, where r0 is the vector associated with the point P, which had coordinates of x0, y0, z0, and r1 is associated with the vector q, which had with the point Q, which had coordinates x1, y1, z1. Now we have a line that goes from r0 to r1, but it's an entire line. In order to turn this into a segment, what we need to do is we need to limit the value of t. It's kind of like restricting a domain. And if we let t go from 0 to 1, then we end up with the desired segment. Here's how I think of how this works. If t is equal to 0, then I have no portion of r1, right? Because I have t times r1. If t is 0, r1 is gone. And if t is 0, then I just have the vector r0. So r of 0 would simply give me r sub 0, the vector. If t is 1, then 1 minus t is going to zero out, and I'm left with the vector r1. As t goes from 0 to 1, the coefficient in front of r0 gets smaller and smaller. The coefficient in front of r1 gets bigger and bigger. And so that's how we end up going from r0 to r1, which is really going from P to Q. So this is a formula for the segment between 2 points.